Instead of dark energy within the known universe, is there a chance something beyond is sucking to cause the expansion of the universe from beyond?
In order for that to happen, there are two assumptions you can make. Assumption number one is, if that were the case, then that means that our observable universe is just a little bubble in a much larger universe. And something around the outside can therefore create that kind of expansion through suction. The other situation might be that if we, as a four-dimensional space-time, were embedded in a five-dimensional membrane, you could imagine that our four-dimensional thing is expanding in the fifth-dimensional thing almost because of something, say, a surface tension. In the same way that, say, an oil slick expands across
the
pond,
surface of the water.
Right, surface of the water when
and
the
it
water
just
is deeper.
it just keeps expanding no matter what.
That's right. Balarasundram and Lisa Randall, they came up with this idea some years ago, suggesting that if indeed our space-time were connected to other four-dimensional space-time via membranes, that might explain things like why gravity is so much weaker on same distance scales as the nuclear force. Because it can extend over long distances, and because it does not have a negative that cancels out the positive, gravity in the universe on cosmic scales has no.
And I always thought gravity was merely potential energy.
Right.
But surely that can't be the case in space because there's no up, no down.
Right. Gravity is not potential energy, but gravity, if you have a particle that's in a gravitational field and that particle has mass, it contains gravitational potential energy, which can then be released if it falls through the system. In space, we don't worry about up or down, Gary, as you rightly say. We worry about whether it's in or out.
Right.
If it's close to or away from some sort of gravitational center. If you have a field and you have a particle in that field that interacts with the field, there's a little bit of energy. When you move that particle in the field, it feels a force and some sort of energy gets released. Depending on where you are in the field, the amount of energy released varies. When you're talking about Hawking radiation in a black hole, there's actually a lot that still needs to be straightened out. Pretty much anything emits something along the lines of Hawking radiation. It's just that for black holes, it's actually important because that amount of emission is the only stuff that's coming away from the event horizon.